Hello student, I would like to continue from the last video. We are discussing about process modeling and we are going through in details about DFD and also other various modeling techniques. Data that should travel together in case of we are displaying data flow in DFD then should be shown as a single data flow, no matter how many physical documents might be included. Here you can say in this example, this telephone service provider communicating with payphone bill process, and we cannot put multiple numbers of data flow to this process. Okay, that is incorrect. We need to choose only one data flow, that is itemized call and invoice, or whatever the name you give, that should be one and the data flow should be one, not in multiple type. So that is the concept. Data that should travel together from one location to another location should be shown as a single data flow, no matter how many physical documents might be included. Here you can see composite and elementary data flows. In the high level DFD, in the first example, or here you can see customer is communicated with process order. That is here you can see that order is composite flow. But this composite flow can be drawn in more detail DFD, that is that customer might communicate with process order in three different ways. First might be this one, second might be this one, third might be this one. Here first one is that process standing order. That is why customer is providing the order in a standing order to process standing order, and customer is providing a rush order to this process rush order. Customer is providing order that is standard order to the standard order process. So all are going to be in single way in this high level one. But if we do a more detailed DFD, we can use this one. So here you can see junction indicates that any given order is an instance of only one of the other types. So here you can see you can use this type of notation but not multiple to a single process. Here that is why for various or multiple data flow it is creating multiple processes. So does it become for every single process only one input from one customer, or we can say single data flow from one process to another process, that through the junction. Okay, junction indicates that any given order is an instance of only one of the border types. Here you can see data flow and from data stores. Here this is the order, that is the data store. There are various processes are associated with this one. Suppose this is input coming like change of address. This is a process change order address. Then it will input that information to the order database. Update. It will update the database. Again, suppose order request is coming for the process order. So new order is coming. So for the new order, that information will be created and stored in the order in the data set. Okay, again cancel order, that is we are going to cancel the order, that is the process, and it will also update or delete the order from the data store. And again, suppose we want to read this summarized summarize unfilled orders, that is a process. Suppose we want to read which orders are unfilled, then we can read from this order, and this data will be go to this process, and that will be go through the users. So that is a data flows. Those are the data flows from data stores. Some are incoming and one is outgoing. So here you can see some rules about data flow. So here illegal data flow is like that. A data flow should never go unnamed. You have to name it. Like here you can see the correct one is this one. And again, in logical modeling, data flow names should describe the data flow without describing the implementation. So you cannot just apply or say the implementation process. You just need to give what is the data that is flowing. The name should be described without describing the implementation. Again, all data flows must begin and or end at a process. Here, in these cases, here you can see a process is needed to update or data store. So first, you cannot pass that flow without labeling it, and again that has to be feedback through that labeling, not directly to the process. That is a process, okay, that is a label process. Okay, here again the data store is giving the information to this one, but you need to name it. Okay, correct data flow B1, and again here you can see two data store cannot communicate, okay, without the labeling. You need to name those label. Next, data conservation. The practice of ensuring that a data flow contains only data needed by the receiving process. This is a practice to ensure that a data flow contains only those data needed by the receiving processes. No extra data. Sometimes called starving the processes. New emphasis on business process redesign to identify and eliminate inefficiencies. Simplifies the interface between those processes. Must precisely define the data composition of each data flow, expressed in the form of data structures. So these are the way to provide the data conservation practice, because we should only flow those data that is required between two processes, not any more or any other data. That is why it is also called as starving the processes. Okay, data attribute and data structures. We are going to discuss this to one. What is the attribute? The smallest piece of data that has meaning to the users and the business. So data attributes should have a meaning, and it should be useful for user as well as to the business, and it is the smallest piece of data with a meaning. Second, what is data structure? A specific arrangement of data attributes that defines an instance of a data flow. Data structure is a specific arrangement of data attributes. Is the arrangement of data attributes which defines an instance of a data flow. The data attributes that comprises a data flow are organized into data structures. So in a data structures there might be lots of other data attributes. The data attributes that comprise a data flow are organized into data structures. So data structures will be in organized form of data flows, and those data flows are comprises of data attributes. Data flows can be described described in terms of following types of data structures. It might be a sequence or group of data attributes that occur one after another, or the selection of one or more attributes from a set of attributes, or the repetition of one or more attributes. So it might be like in a sequence or group of data attributes which occur one after another, not simultaneously, or some data should be like it will occur, or it will go, or it will flow upon selection one or more attributes, or some data structure might be like repetition of one or more attributes constantly. So like here you can see data structures. Here is a data structure. Our order is a data structure, or address is a data structure. What are the data attributes might be contained here is like order number, order date, personal account number, corporate account number, shipping address, okay, billing address. So all these attributes, all these are attributes, and these are with different notation. And instances and the interpretation of this data structure in English is like that. An instance of order consists of order number and order date, and either here you can see this square bracket. Okay, square bracket. In square bracket you can say either personal account number or corporate account number, and shipping address, which is equivalent to address, this is the symbol which is equivalent to address. And optionally, that is why this is first bracket. Okay, this is the first bracket, and which is why billing address is optional, which is equivalent also to the address. And second, in the one more instance of product number, product description, quantity order, product price source, extended price, and sum of extended prices, and prepaid amount. And optionally, here you can see optionally both credit card number and expiration date. That is another instance going to be included in that order. So in the whole instance of order will include this. Okay, first it will include this, where either means we have to provide this square bracket. Okay, that is why this is a data structure format. It might be different in different cases, but for understanding, this is the example and how we can interpret in English meaning. So here you can see again, suppose data structure sequence of attributes are there. The sequence data structure indicates one or more attributes that may or must be included in a data flow. Like here you can see, for example, wage and tax statement. Suppose taxpayer identification number plus taxpayer name, taxpayer address, wages, tips and compensation, federal tax withheld. English interpretation is like that. An instance of wage and tax statement consists of taxpayer identification number, taxpayer name and taxpayer address, wages, tips and compensation, and federal tax withheld. So that is the sequence of attributes. That sequence of data structure indicates one or more attributes that may be included in a data flow. So in a single data flow, all this information will be included. And the selection of attributes, the second type, the selection of data structure allows you to show situations where different set of attributes describes different instances of data flow. Suppose this is the example: order equal to personal customer number, comma, corporate account number plus order date. So here the interpretation is that either personal customer number or corporate account number. So that is the selection. we are selecting one of them only in the data flow, not all of them. That is selection of attributes. But in this case, in the previous case, that is sequence of attributes. And if you want to do repetition of attributes, here you can see repetition of data structure is used to set up data attribute or group of data attributes that may or must repeat themselves a specific number of times for single instance of data flow. The minimum number of repetition is usually 0 or 1. The maximum number of repetition may be usually defined as n, meaning many, where the actual number of instances varies from each instance of data flow. So in a data flow, it might be 0 number, it might be 1 number, it might be n number. Generally 0 and 1 are placed in case of minimum number. So repetition of attributes is like that. Some attributes might become in repetition in a single data flow. Here you can see policy number plus, policy holder name plus, policy holder address plus, 0 dependent name plus, dependence relationship plus, n plus 1 expense description plus, service provided plus, expense amount. So here you can see an interpretation is that an instance of claim consists of policy number and policyholder name and policyholder address n, 0 or more. That is why here you can see there you can see 0 and n, 0 or more instances of dependent name and dependence relationship and 1 or more instances of expense description. And here one or more instances of expense description, service provider and expense amount, or you can say account, and you can give as is only data attribute. So these are the scenario about data structure, different type of types or different type way to name them, or different type of interpretation, or different type of way to so that how the data is flowing. There are other data types like optional attributes, there are reusable attributes. So try to go through this slide also. This is for your reading purpose. So again, data types and domains. Data attributes should be defined by data types and domains. Data type is what? A class of data that is stored in an attribute. It might be character, it might be integers, it might be real numbers, it might be dates, pictures, etc. And domain is the legitimate values for an attribute, or you can say range of an attribute. Okay, there should not be any attribute value which is not in the domain or in the range. A class of data that is stored is an attribute. So that should be a data type. Again, next, diverging the data flow. A data flow that splits into multiple data flow, we need to diverge those data flow. Indicates the data that starts out necessarily as one flow, but it is routed to different destination. It might be, in case of composite case, we have seen in the previous slides. And also useful to indicate multiple copies of the same output going to different destination. So if you are dividing your route to different location, then for every route you need to provide a specific data flow notation. Means you are going to use multiple copies of the same data flow, as the flow is going for different destination in a different route. Then that is about diverging the data flow. And again, converging data flow is that the merger of multiple data flows in a single packet. There might be like in a single packet you are merging different data flow. Indicates the data flow from multiple sources coming and that come together as a single packet for subsequent processing. So here you can see the example. This ABC is converging and inputting to this process, and here you can see UVW diverging data flow is diverse to different data flow, multiple copies. And again there might be single hij or output rst single output, or same type of data but multiple copies at which might go in different location and merge with another one, okay, like that. And again here you can see merging is converging or merging, or this is diverging, okay. So in that way data flows are converged or diverged. So when to draw process models? That is a very big question. When do we need to draw system process models? One, when you need to strategic system planning. Enterprise process models illustrate important business function, and in that scenario we need to draw process model. And in case of you need to draw a business process redesign, as is process models facilitate critical analysis. That is why I need to draw the process models. And to be process models facilitate improvement, to improve the facilitation process or to provide the facilitation for critical analysis and for system analysis, which is actually our main focus in case you are a system analyst or a designer for a information system. Model existing system including as its limitation. We need to understand the limitation. That is why we might need to draw the process models of the existing system also, or we need to know the process models of the existing system also. Model target systems logical requirements. We need to understand the logical requirements. Third, model candidate technical solution. It might provide candidate technical solution, which solutions will be preferable, and that candidate technical solution will be accepted, and model the target technical solution. So not only choosing the candidate but also targeting the technical solution. So these are the answer of the when to draw process model. So we'll go through this classical structured analysis process, how we go through this in the next video. As we have already told, I have already told in the previous video that this video is longer one, so I have partitioned in many parts, in 4 parts mainly. So we have covered this much till second video. I'll provide 2 more video from these same slides and try to go through it. If you have any doubt, please let me know. Thank you.